Hello folks, this is going to be a quick one. Give this one a shot. If you're not familiar with this type of questioning, it's popular on the GRE, but the types of questions are on the GMAT, the SAT, Algebra, Geometry, you name it. What is bigger, area A, which is square 3, or area B, which is squares 1 plus square 2? And if A is bigger, then the answer is A. If B is bigger, then the answer is B. If they're equal, then the answer is C. And if it's undeterminable based on the information given, then the answer is D, like David. So give this one a shot and see what you think, if area 3 is bigger or areas 1 plus 2. And those are all 3 squares, by the way. Hit the pause button if you want to give this a shot, and then we'll do it together. Okay folks, I hope you tried it on your own. Now let's try it together. Let's see if we could have some fun and draw some right triangles here. We have, that is 90 degrees right there. So there we have a right triangle here, and then we're going to have a square. Then let's draw it to scale, or as much as possible. Okay, we're going to have a square here, and then we're going to have a square here. And then this is number 1, number 2, number 3, and they're all squares, right? Now the question is, A is square number 3, the area of square number 3, and B is square 1 plus square 2. And the question is, what's bigger, A or B, or if they're equal, or if it's undeterminable? If you look at this, we know the Pythagorean theorem. We know that this is, let's say this is A and that's B and that's C. We know that A squared plus B squared is going to equal C squared, which is funny because that kind of gives us the answer, all right? Because the area of A, of square A, is A squared, right? That's the area of square 1, that's A squared. And then the area of that square 2, right? That's B, right? This is B, this is B, this is B. So the area of 2 is B squared. This square is B squared, and this square is A squared. And then the hypotenuse is right here, this guy right there. And then the area of square C would be, obviously, so this is a square, so all these sides are C, is C times C. This is C squared. We have, what is bigger? A squared plus B squared, which is this, or C squared, which is this. But we know from the Pythagorean theorem, come back up here, we know that A squared plus B squared equals C squared, right? Ba-ba-da-ba. They have to be equal. That's the answer. They have to be equal. So A and B are equal to each other. So the answer there is C, because they're equal to each other. I had one student ask me, you know, things like, oh, what if the triangles look like this? You know, even if it looked like this. He was really trying to trick us here. All right, with it, you know, that's a tough one, right? It doesn't matter. Even if this is A and this is B, okay, and this is C, and then the squares, you know, are like this. All right, that's obviously not drawn to scale. It looks more like a rectangle, but pretend it's a square, right? And then this square would go something like way out here, right? Nonetheless, even if it was this goofy little shape here, we would still have this square plus this square has to equal this square, because this square is A squared, this square is B squared, and this square over here is C squared. And we know from the Pythagorean theorem that A squared plus B squared equals C squared. So it doesn't matter what the dimensions are, as long as that angle right there is a right triangle. Good stuff. Great question. Feel free to subscribe if you want to keep getting these. I love these questions, and keep kicking butt on this exam.